Okay, we're going to talk about 2.1 conditional statements. And a few terms we need to know first if we're dealing with a conditional statement. We need to know, well, first, what a conditional statement is. And typically, a if-then statement is generally how we see conditional statements. So, if-then is usually our conditional statement. So, for instance, in this one, if two angles are congruent, then they have the same measure. Okay, and what we have here is a hypothesis. The two angles are congruent. That is our hypothesis. And a conclusion. The conclusion is directly tied to our hypothesis. We're able to conclude something based on what the hypothesis says. So in order for us to be able to function, we have to have a true hypothesis here. So the two angles are congruent. That's something that can happen. Therefore, we can go to the conclusion and say, well, we can make a statement about those angles. In this case, they have the same measure. Okay, and two angles being congruent, meaning they have the same measure, the truth value to that is actually, this is a true statement. Okay, when two angles are congruent, they have the same measure. Okay, if we look at a different one, say this time, if it snows, so it snows would be our hypothesis. Our conclusion then, our conclusion would be school is canceled. Okay, so here we're saying if it snows, school is canceled. Is that true? Well, not always. It's snowed before and school hasn't been canceled, so this isn't always true. Therefore, the truth value is false, at least in our area. All right. So those are conditional statements. If-then statements are typically called conditional statements. Each one contains a hypothesis and conclusion. To function, we have to have a true hypothesis in order for us to move on to the conclusion. Otherwise, from there on out, it really doesn't. The conclusion can't rely on the hypothesis if the hypothesis isn't true. And in this case, if they're both, the hypothesis and conclusion, make a true statement, then the conditional statement is true. If the hypothesis and the conclusion, if they're both possible, but necessarily school being canceled is not reliant upon it snowing, then in this case, that's a false statement. The truth value is false. Okay. Some other things we need to know. First, if-then statement. Notice I've now changed it just so that we can, I've made our hypothesis letter P. Okay, so P equals hypothesis. Okay, and I've made our conclusion. Please forgive me if I don't use the same color, but Q. Q equals conclusion. That does not look like the same color, but I think you'll get the point. Okay, conclusion, Q. All right. So what I'm going to do here is show, rather than having big long statements, I'm going to say if P then Q. And that's important because what we're going to do with this is we're going to start adding different statements. A converse statement where we actually switch our hypothesis and conclusion. So really that is actually saying if Q then P. So these things just move. So the P moves to the conclusion, the Q moves to the hypothesis. All right? And then there's this thing called negation. Negation means you are making, some people like to think of it as being the negative statement in terms of math. It's putting not in front of our hypothesis and conclusion. So the inverse statement is just saying if not P. So it's taking our conditional and putting not in front of it. If not P, then not Q. And the contrapositive is negating our converse statement. It's saying, well, if not Q, then not P. Okay? And one thing to keep in mind here, that let's say if we go back to our if-then statement here. If two angles are congruent, they have the same measure. If we say if two angles are not congruent, then they do not have the same measure. Sometimes they can be true and sometimes they can be false. Okay, and we're going to see that here in a minute. Okay, I'm going to go through and work each of those out. So some symbols we need to know. First, the way we write this mathematically is we say this, P, then Q. Okay, this would be Q, then P. Okay, this would be negation is that symbol there. Okay, so if not P, then not Q. And this would say if not Q, then not P. Oops. All right. Forgive me for not using the colors there. All right. Moving on. So let's try to put these into play here. So if two angles are congruent, then they have the same measure. We already know that's true. Okay. Our converse just switches this around. This one says, now we take the same measure, we move it here. Angles are congruent, move it back here. So if two angles have the same measure, then they are congruent. Well, if two angles have the same measure, say for instance both 60 degrees, then they'd have to be congruent because they're equal. We also would say that that is true. Okay, well, let's go ahead and move on. If two angles are not congruent, okay, so we're adding not in front of our conditional statement, then they do not have the same measure. Okay, now this inverse statement really ties to our converse. Even though it looks a lot like the conditional, think of our converse. It's true. It's saying if two angles have the same measure, then they are congruent, which really means if they're not congruent, then they don't have the same measure, and that's what this is saying. If the angles are not congruent, then they don't have the same measure. Okay, it's just another way of saying your converse statement, even though it looks like your conditional statement. And the same applies when you're dealing with contrapositive. Really, in contrapositive, you're putting the word not in front of the converse. So you're saying if two angles do not have the same measure. Okay, notice the similarity between that statement and that statement. Okay, then they are congruent here. Then they are not congruent. But really, it ties a lot to the conditional, because the conditional says if two angles are congruent, then they have the same measure. And then if you read it backwards and put not in, you say, well, if they don't have the same measure, then they can't be congruent. And that's really what contrapositive is saying. So if you read them together, the conditional and contrapositive, and kind of go forward with conditional, if two angles have the same or if two angles are congruent, then they have the same measure. And then kind of work backwards, adding the word not. If they don't have the same measure, then they are not congruent. Okay? So it's just another way of saying, contrapositive is another way of saying the conditional a lot of times, and inverse is another way of saying the converse a lot of times. Okay, so we put a ton of different stuff there, and you really need to learn these four types of statements. So your contrapositive statement, converse, inverse, and conditional statements. There's one more statement we'll talk about here in a minute. Okay, but before we do that, I want to go through, oh, and by the way, we never finished our truth value on this. Inverse statement, if two angles are not congruent, then they do not have the same measure. So if they're not congruent, they can't have the same measure. That is also true. And this one, if two angles do not have the same measure, then they are not congruent. Okay, that's also true. All right, so all those are true. Let's move on to our snow one. If it snows, then school is canceled. So the converse, we switch it around. If school is canceled, then it snowed. We know that this first one was false. If school is canceled, then it snowed. I think back to last year, at least at our school, we had some different wind problems a couple of years ago. I don't know if it was last year, but and school got canceled. So just because school is canceled doesn't mean it snowed. So that's also false. Okay, and then the inverse. Well, if it has not snowed, then school is not canceled. Okay, well, if it has not snowed, then school is not canceled. Well, let's do the contrapositive as well for a minute. If school is not canceled, then it did not snow. Okay? Let's take a look at this. Let's do conditional. If it snows, then school is canceled. And if school is not canceled, then it did not snow. That's what we're saying here. So if school is not canceled, then it did not snow. That is a false statement. Okay? We've had situations where it has snow and school has been canceled. Okay? And it has snow and school hasn't been canceled. So that is a false statement as well. And going back up here, if school is canceled, then it has snowed. And if it hasn't snowed, then school is not canceled. Also a false statement. Okay? If it hasn't snowed, then school is not canceled. It's not a true statement when we're talking about canceling school because of snow, because once again, like we said before, school can be canceled because of other reasons. All right. The last thing we do, the last statement is called a biconditional. And a biconditional says, hey, if the conditional is true and the converse is true, then we can write a biconditional. So once again, if P then Q is true, and if Q then P is true. This one's true. This one's true. If those are both true, okay, then what we can do is write a biconditional. Biconditional says the conclusion, or excuse me, the hypothesis, if and only if the conclusion. So, and the way we write that is P, and we put Q, but we put an arrow on each end. Okay, P, if and only if Q, and that can only happen if both conditional and converse are true. Let's see that with our angle one. If two angles are congruent, then they have the same measure. We knew that was true. The converse was also true. If two angles have the same measure, then they're congruent. So now what we do is we take our hypothesis and conclusion of our conditional statement. Okay? So let me erase this part so we don't have any confusion here. We take our hypothesis and conclusion of the conditional, and we write it in a biconditional. Hypothesis first. Two angles are congruent. They have the same measure. Conclusion second. And we put the if and only if in between. So two angles are congruent if and only if they have the same measure. That is a true. All right. Okay, the other thing we talk about here are called truth tables. Okay? And truth tables work like this. Okay? They help you to determine under what circumstances a conditional, converse, inverse, or contrapositive statement is true or false. So it's just a quick way to take a look and see if those are true or false, and if you have equivalent statements. Okay, so your different options. Remember, P is our hypothesis. Q is the conclusion in all of these. So the different scenarios you can have. You have a true hypothesis and a true conclusion. You could have a true hypothesis and a false conclusion. You could have a false hypothesis and a true conclusion. And you can have a false hypothesis and a false conclusion. Okay, so really what this means, I think it's pretty easy to say, hey, if you have a true hypothesis and a true conclusion, it's easy to determine that it's a true statement. The conditional statement is going to be true. And if you have a true hypothesis, that means you can go on and look at the conclusion and say, well, if I have a true hypothesis but a false conclusion, that's pretty easy to say, hey, that's false. You can't have this, your conclusion being, or your hypothesis being true, and then the conclusion that depends upon the hypothesis being false. That doesn't work there. All right, here's where it gets a little tricky. When you look at your hypothesis, if your hypothesis is false, it really doesn't matter what your conclusion says, because your conclusion is dependent upon a foundational hypothesis that would have to be true. Okay, so when we look at a hypothesis that is false, we can kind of almost ignore what the conclusion says because this is a false statement. Okay, and what we know is that false statement is truly false. So it's true. And this false statement, no matter what the conclusion says, is truly false as well. And I know that seems weird, but in order for you to be able to move on to your conclusion and base it upon logic, you have to have a true hypothesis. If your hypothesis isn't true, your conclusion doesn't really hold any water. Okay? All we know is that we truly have a false hypothesis, and that's why this is true. Okay? Kind of weird. So really, if you look at this, the only time you get a false statement for conditional is when you have a true hypothesis and a false conclusion. Now let's move on to the converse here. Once again, we're going to start with the exact same pieces that we had for our conditional. It's just the only thing that's going to change is that rather than having P then Q, we have if Q then P. So we kind of read it backwards. Some students even like to have this and then they rewrite the Q over here so they can look at it in the correct order. I just look at it in this order. I go, okay, if Q, then P. True, true, that's true. If Q, then P. Well, if my hypothesis is false, remember, it doesn't matter what my conclusion says, that is going to be true. If true, then false. Now remember, you can't have a true and then a false statement. You have a true hypothesis, you can't have a false conclusion. That's your false situation. And if false, then false. Remember, if false, it doesn't matter what the conclusion is. If you start out with a false, you're going to end. You know it's truly false, you're going to end with true there. Okay. So the only place you can get a false here, remember, is if your hypothesis is true and your conclusion is false. Okay? So it's kind of reading it backwards, so that's why a lot of students like to sometimes write the Q over here and redo that so that it looks a little more clear, and then they kind of ignore that area and they really just focus in on this column and this column and go in that order. And when you do it like that, when you just focus in here, then really you end up with the same type of table that you had over here. Notice true, true is true, 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 false, true, true, okay, false, true, 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 false, false, true, false, false, and false, false, true, false, false, true. Okay, so you can kind of think of it like that. It makes it a little easier. That's up to you, though. Okay? All right, those are our truth tables. Okay? Remember what there. All right. So we're now going to move on to inverse and contrapositive. Once again, that's what our truth tables do. I am going to go ahead and I'm going to fill in again my true, true, false, false for my conditional, and then my true, false, true, false. And then I'm negating them. I'm going to say, well, I'm going to negate true. All right? When we negate true, really what we're saying is the opposite of true, if you think of it that way. And so the opposite of true is actually, by negating true, the opposite of true, that's not erasing for some reason, so you know what, we're just going to scribble it out. The opposite of true is false. Okay, and if I negate P here, so negating it, the opposite of true here is also false. Okay, and maybe if you want, it may, rather than me scribbling all this stuff out, maybe it's helpful to just see it in this fashion. You say, that's actually false. You say, we're negating true here, that's also false. When we negate false, you actually have true. And when you negate false here, you actually have true. Okay, and so, let's say we just focus in right on this piece right here. Okay. Okay, now I don't think I'm going to do that on this next part, but if we negate Q, so the opposite of true is false, the opposite of false is true, the opposite of true is false, and the opposite of false is true. And so now we're looking at these two columns right here. Okay, that's what this statement tells us. We're saying, hey, if this, then this. So we just follow the same guides. A false, false, if our hypothesis is false, it doesn't matter what our conclusion says, we're basing it on a true false, a truly false statement. If our hypothesis is false, doesn't matter what the conclusion says, it's a truly false statement. However, if the hypothesis is true and the conclusion is false, that's a false. If the hypothesis is true and the conclusion is true, that's a true. Okay, the last one started off exactly the same, a contrapositive. All right. Hopefully this one be a little easier, kind of. So negative Q. Okay, then negate true, which is false. Negate false, which is true. Negate true, which is false, and negate false, which is true. And negate true, which is false. Negate true, which is false. Negate false, which is true, and negate false, which is true. Meaning that here, when we focus on these, focusing here and here, just remember it says Q first and then P. So we are focusing here and then here. Okay, so looking at it, we can have false, false, which is true. True, false, which is false. False, true, which is true. True, true, which is true. All right, those are truth tables. And yeah, pretty interesting stuff there. And just remember this, okay? Two statements. Oops. My goodness. Must be time for me to be done here, I guess. Okay, two statements are logically, that's what you're dealing with here, logically, dealing with logic, logically equivalent if they have the same truth tables. Okay, two statements are logically equivalent if they have the same truth tables. All right, that's it for today. Woohoo!